Bismillah ar-Rahman ar-Rahim. My name is Dr. Ahmad Azzazi. I would like to represent you the third part of the first module of the open course Computer Organization and Architecture at the Applied Science University at the Faculty of Information Technology, with the title Computer Evolution and Performance, the second part of it. The prerequisite for this course is the Digital Logic course. We have here the course description of this course, the textbooks, and a reference for the textbooks. Okay, as we are describing the history of computers, we are now going to talk about commercial computers. In the year 1947, Eckert and Mauchly Computer Corporation introduced the Universal Automatic Computer number 1. Late in the year 1950, the Universal Computer 2. It was a faster computer with more memory. IBM also introduced the punched card processing equipment. In the year 1953, the Computer 701. It was the IBM's first stored program computer for scientific calculation. In the year 1955, the 702. It was designed also for business applications, which lead to the 700 and 7000 series of computers. The transistors, they played a major role in the evolution of computers. They replaced vacuum tubes. They are smaller, cheaper. They use less heat dissipation. They have a solid state device. They are made from silicon. Silicon is a major substance of sand. Invented in the year 1947 at Bell Labs. Transistor-based computers were then the next generation, the second generation machines. The NCR and RCA companies produced small transistor machines. IBM also produces the series 7000 based on transistors. The rise of microelectronics, which means small electronics. A computer is made up of gates, memory cells, and interconnections. These can be manufactured on semiconductors like silicon wafers. We can describe the or summarize the generations of computer as vacuum tube computers from the years 46 to 57. Transistors based computers from the year 58 to 64. Small scale integration of all these transistors in the year 65. We have up to 100 devices on a single chip. Then we have a medium scale integration to until the year 71. About 3000 devices were placed on a single chip. For a large scale integration from the year 71 to 77, we have about 100 devices on a single chip. Then we have the very large scale integration from the year 78 to 91. We have up to 100 million devices on a single chip. We have then the ultra large scale integration. It is from the year 91, over 100 million devices of microelectronics on a single chip. Moore is a person who was a co-founder of Intel Chip Corporation. Intel is specified on producing microchips. Moore's law, we could describe it as the following: increased density of components on a chip yearly. The number of transistors on a chip will double every year. Since the 70s, development has slowed a little. Number of transistors doubles every 18 months. The cost of chip has remained almost unchanged. Higher packing density means shorter electronic paths, giving higher performance. Small size give us increased flexibility in developing different systems. We have then reduced power and cooling requirements, and fewer internet connection increases reliability also. This is the growth in CPU transistor count from the year 1970 until the year 2010. We have about 1,000 transistor per chip until 1 billion chip transistor CPU. This is a major development. It was linearly increasing development or doubling in the count of transistors. The relationship among all of these things: we have the wafers, plates over each other, which makes up a chip. All of these wafers containing the electronic kits packed into a packaged chip with different pins to be placed on the motherboard.